So Ibrahim, Ilknur, Adilhan, guys, welcome back. And again, once again, Happy New Year. I hope you are all doing well. Ibrahim, are you okay? How are you?
Good.
Good. I'm also good, thank you. Adilhan, how about you?
Good.
Okay, I think you're so tired, no energy. Maybe you're sleeping. Anyway, guys, let's start. Okay. As you remember in the previous chapter, chapter 8, it was about perimeter and area of simple figures. Now I am going to start chapter 9. After that, maybe we will do a few revision. Okay. After this, Ibrahim. And let me also finish this chapter 9. And after that, we have chapter 10. And after that, we will do some revision. I think I have already shared this chapter 8 exercises with you. You are supposed to practice those questions. And let's see. So today we will talk about volume and the surface area, chapter 9. So when we just talk about surface area and volume, we talk about, what is it, three-dimensional figures. And in the previous chapter, we talk about, what is it, perimeter and area. That is two-dimensional figures, right? Every time if you want to calculate the area, we need to know it is base and we need to know it is height, right? If we talk about a triangle, for example, let's say if we know the base and height, base times height over 2, it gives us the area. The area means how much space is it covering on the floor, let's say. And how about the rectangle? Length times width, right? How about the trapezium? The sum of the parallel sides over 2 times h, and blah, blah, blah. But now here we will talk about a more realistic things, not realistic, let's say, the solids that we can touch, right? Okay, so surface area and volume are calculated for any three-dimensional geometrical shape. The surface area of any given object is the area covered or region occupied by the surface of the object. For example, you can just take your own body, our surface area, right? Or, for example, a kind of sphere, for example, basketball, for example, right? A kind of cuboid, for example, or water tank. These are all three-dimensional objects, right? If you want to, for example, paint your house, for example, let's say you may be interested in how much paint is needed to paint your house. Okay, guys, let me just give me 1 minute. Let me give a message to Mr. Adalat who are here. All right, let's get back to our slide. So now, what are we going to learn in this chapter? We are going to learn how to find the volume and surface areas of cubes and very, very simple objects, cubes, cuboids, prisms, and cylinders. And also after that, we will solve problems involving volumes made up of the above solids, right? Composite solids, let's say. So as I see in the picture, the first one is, what is it? It is a prism. Right? Prism means every cross-sectional area. If you just cut this with a knife that is perpendicular to the ground or to the floor, the cross-sectional area, as you see, it is a triangle. It may be a triangle, it may be a trapezium, it may be a rectangle. If every cross-sectional area is the same in any polygon, we call this a prism. And here in the second picture, we see a pyramid, right? Pyramid is actually just pointing towards each other, and the base is a polygon. For example, if the base is square, we just call this square base pyramid. If it is a rectangle, we say rectangle base pyramid. If it is a pentagon, pentagon base pyramid. And how about a cylinder? Cylinder is every cross-sectional area, right? If you just cut this with a knife parallel to the ground, you will see that the top is a circle. And like every pipe is cylindrical shape, for example. And also cone, right? What is that? Is a birthday cap. Or cone, for example, usually if you want to eat ice cream, right? You just usually people sell ice creams in cones. And sphere, like football, volleyball, tennis ball, these are all examples for spheres. Now here the question is, how do you find the air volumes, or how do you find the air surface area? So we will talk about this stuff. I mean, this is very fundamental basic stuff. And more in detail, we will learn in our next book. So the picture below shows a piece of wood, a brick, and a matchbox. Okay, as see here, the first one is wood, the second one is brick, and third one is matchbox. So which of them occupies the least space, right? Or another question is, let's say we have a kind of container. Let's say we have a kind of container, a big container, and you can just fill this with water, okay? And filled with water till the mouth of this container. All right. And if you just put these objects, first I'll just put the wood. And since the water is full here in this container, right? If you just put this wood completely into the water, some water actually flows outside the container, right? And how much water comes out? Actually, that gives us the volume of the wood. And how about brick? In similar way, if you just soak that brick into this, uh, the container which is filled with water, again some water comes out, right? It's like a bathtub. If you're going to, for example, dive into the swimming pool, right? The water gets out of the swimming pool. So also brick, if you just actually soak this into the container, some water comes out. And also that the water, the amount of water that comes out, it gives us the volume of this brick. And also matchbox in a similar way. Anyway, to compare these things actually, which of them occupies the least space? How do we answer this question? To answer this question, we need to know the air volumes. So if you just calculate the air volume, how much space do they occupy in the air, for example, then we can compare which one occupies more space, or which one occupies the least space. So the volume of an object is, it should be is the amount of space it occupies. The object that occupies more space is said to have a greater volume. Immediately, let's just see usually what units actually we use to measure the fluid, I mean the volume of the fluid. We know that for distances we use either centimeter, right, or meter or kilometer. How about for volume? We use milliliter or liter or kiloliter. Later also we will see that, and also we will use cm cube and the meter cube and the kilometer cube, if it is so big. Actually, usually most common units are centimeter cube, meter cube. What is centimeter cube? And also let me just tell you here, if we are given a cube of side 10 centimeters, let's say we are given a cube, all right. So if we are given a cube whose side is 10 centimeters, okay, this one is 10 cm, 10 cm, 10 cm. Okay, now the question is, how much space does it occupy? So this volume is equal to 10 times 10 times 10. That's equal to 1000 cm cube. All right, so 1000 cm cube. That actually 1000 cm cube, we just actually define this as 1 liter. Okay, so what is 1 liter? 1 liter is a kind of container, let's say cube, whose size are 10 centimeters each. Okay, so that container holds 1 liter of, let's say, water. So what is 1 liter? It is 1000 cm cube. And we know what is milliliter from here. Milliliter means, milli means 1000, right? So we know that 1 milliliter is equal to 1 over 1000 liters. And how about liter? We know that 1 liter is 1000 cm cube. How about kiloliter? Kiloliter is 1000 liters, because kilo means 1,000, right? These are the units that we use to measure the volume of liquid. Okay. So volume of fluids express 1 centimeter cube in millimeter cube. Okay, guys, Selen, you are here. Let me just here this present, and Alekbar absent, and Nigar absent. Okay. All right. So how do we convert one unit to another units in volumes or related to volumes? It says that 1 centimeter cube into millimeter cube. Again, we should understand what we mean by 1 centimeter cube. So 1 centimeter cube, what we mean by 1 centimeter cube? Let's say volume equals 1 cm cube, right? So actually we mean, again, we mean a cube whose side is 1 centimeter. All sides are 1 centimeter. Here, okay. This one is 1 cm, 1 cm, 1 cm, right? So if I want to change this into millimeter cube, what is 1 centimeter? We know that 1 centimeter is equal to 10 millimeters, right? So at the time, this one is 10 millimeters, this one is 10 millimeters, right? And how do you find this volume? This volume is 1 cm times 1 cm times 1 cm. And simply, what is it? It is 1 cm cube. Now, instead of 1 cm, if I substitute 10 millimeters, what do we have here? 10 mm cube. So what is 10 cube? 10 cube is equal to 10 times 10 times 10. That's equal to 1,000. How about millimeter cube? That is just mm cube. Okay, Celine, are you there?
Yes.
How are you today? I think you're having holiday, right? Or you had class today?
We have holidays till Wednesday.
Till Wednesday.
Yes.
I see. So is quarantine over, or still you have to get all your classes
No.
online?
Online.
Online. So until when?
Until Wednesday. Like in 2 days, I think so.
No, I mean your classes will be online. How long more?
I think so till March, but we think that on March we have holidays, Nowruz Bayram, and then that's why we'll have like in June, maybe certain already holidays. That's why I think so. We will not have school.
So is the situation that bad in Azerbaijan?
I think so. Not that bad that we say, but in internet there's written like 2,000 maybe in one day.
Yeah, because the quarantine
People.
time is so long. So almost 1 year you are staying home, right?
Yes.
I see. Okay, good. What can we do? In Cambodia, we are going back to school starting from last week. So today I taught my first class in the classroom, and let's see. So now everything is getting back to normal life here. Actually, the normal life, everything was good, not closed, but only schools and university were closed for like 3 weeks. Okay, let's continue. That is how we convert this. Okay, we should understand by 1 cm cube means we are talking about a cube. And that's what we call this cube. One side is 1 centimeter, 1 centimeter, 1 centimeter. So I should change this to millimeter. If you multiply this, or also in this way, simply 10 millimeter cube, 10 cube is 1,000, millimeter cube is millimeter cube. And how about the second question? That is part A. And how about part B? Part B, let's change our marker. 1 meter cube or cubic meters in centimeters cube, right? So again, we know the 1 meter cube, 1 meter cube. What does it mean? It means here we have 1 meter cube. That is 1 meter times 1 meter times 1 meter. Again, we are talking about the cube. The length of each side of this cube is 1 meter. And since we have to actually convert this into cubic centimeters, so I had to change this 1 meter into centimeters, right? We know the 1 meter equals 100 centimeters. And here we have cube. And what is 100 cube? 100 cube is 100 times 100 times 100. That is 1 million. That is 1 million. 6 zeros. And here we have cm cube. In some short form, as you know, that if we have 1 million, also I can just write it as 10 to the power of 6 cm cube, right? 10 to the power of 6 means 10 is multiplied by itself 6 times. All right, express. The first one is A, 3,600,000 millimeter cube in centimeter cube and in milliliter. Okay, so here in part A, millimeter cube, right? We should change this into centimeter. Now from here, 3,600, and 3 more zeros. And what is millimeter cube? Again, millimeter cube, 1 millimeter, right? 1 millimeter. I can just change this into centimeter. We know the 1 centimeter is equal to 10 millimeter. Now, if I divide both sides by 10, that means that here we have 1 millimeter will be equal to 1 over 10 centimeter. That means that 1/10 of 1 centimeter equals 1 millimeter, right? Because we should just 1 centimeter divide this into 10 equal parts. Each actually partition or the length of interval is 1 millimeter. So here I can just write 1 instead of 1 millimeter, 1 over 10 centimeter cube. So now here we have 3,600,000. And how about 1 cubed? It is just 1 over 10 cubed, that is 1,000. And here we have centimeter. Here we have cm cube. So 1, 2, 3, 1, 2, 3. They cancel out each other. Here we have 3, 6, what is it? 360 centimeter cube. And how about milliliters? To change into milliliters, we know that 1,000 centimeter cube is equal to, what is it? 1 liter, right? Or that is 1,000 milliliter, because 1 liter is equal to 1,000 milliliter, right? Because milli means 1,000ths. So instead of this 1 liter, I can just write here 1,000 milliliter, 1,000 milliliter. And what is the question? I had to change this 360 cm cube into milliliter. So here we have 360 cm cube is how many milliliters? And cross multiply. Here we have 1,000. Actually, from here, as you see here, 1,000, right? If you just cancel out these zeros, that means that 1 cm cube is equal to 1 milliliter. So 1 cm cube is equal to 1 milliliter. I'm using this one, since 1 cm cube equals 1 milliliter, 360 centimeter cube, 360 cm cube should be equal to 360 milliliters, right? Okay. In a similar way, how about question B? Question B, 0.7 meter cubes. So now we can do this a bit faster. Adilhan, do you understand?
Yes.
Good. So 0.7 meter cube. Now I can just write this. We need to change this into centimeter, right? 0.7 times, what is 1 meter? 1 meter is 100 centimeters. And here we have cube. That's equal to, and here we have 100 cube. We know that it's 1 million. So here I have 0.7 times 1 million. Let me just write here 10 to the power of 6. And here we have cm cube, which is equal to, I can just write it 0.7 times 1 million. That's equal to 700,000 cm cube. Okay. So now we need to change this into liters. We know that 1000 centimeter cube is equal to 1 liter, right? Here, from here, 1000 cm cube is equal to 1 liter. Using this one, part A, part 2 is 700, 3 more zeros, cm cube. I can just write it as 700 times 1000 cm cube. And what is 1000 cm cube? It's just equal to 1 liter. So that's equal to 700 liters. So that means that 0.7 meter cube is or holds how many liters of water? It can hold 700 liters of water. Celine, any question?
No.
Celine, did you have time to practice those SASMO questions? Did I give you SASMO questions?
Like, yes, I had time. I do sometimes.
Could you solve those questions?
I didn't finish yet, so there's some pages left.
I mean, what do you think? Can you solve the questions, or they are too hard, or they are too easy, or it's normal?
They're normal, like some are easy, some hard a bit.
Yeah, but most of the questions are tricky questions, you know. You
Yes.
think that it's so easy, but if you just miss one point and you cannot answer the question. Okay. All right, good. All right, let's continue. The figure below shows, not below, here on the right, shows a rectangular cuboid. Rectangular cuboid is, as see the bases, all actual faces are rectangle, right? Cuboid, 9 centimeters long, 7 centimeters wide. Given that the volume of the cuboid is 315 cm cube, find the height of the cuboid and its total surface area. Not surface area, it says total surface area. Total surface area means we need to actually find the area of all the faces and add them up. So let's say the height of this cuboid is h, a. And how do you find the volume? Volume is equal to base area times height, right? What is the base area? Base area is a rectangle. That's equal to 7 times 9 times h. And the volume is given. It says that the volume is 315. So we know the volume, that's 315. So we need to find the height. From here, so h is equal to 315 over 7 times 9 is 63. 63. And if you divide 315 by 63, that's just equal to 5. So dot, dot, dot, the height of this cuboid is 5 centimeters. And how about question B? In question B, it says the total surface area, right? And we know that all the faces of this cuboid are rectangles, right? So that means that the opposite sides, right? It's like, suppose that, imagine that now, right now, you are sitting in your room, right? And around you, how many walls do we have? We have 4 walls. And also we have the ceiling and we have the floor, right? I mean, the area, we know that opposite walls have the same area. And also the ceiling and the floor, they have the same area if they are identical. It is something like this. So to find the total surface area, let's say it is S, that's equal to 2 times, usually let's say W is width, length is length, L is length, height is h. How do you find that? W times L, that gives us the area of the bottom and the top. So that is the floor and the ceiling. That's why we are multiplying this by 2. I don't have to just write WL, WL, right? Plus, how about this side? Actually, that's equal to 9 times h. So that is length times height. Plus, and how about this side that's facing to you? That's equal to 7 times h. That is W times h, right? Because all faces are rectangle and the pairs, because opposite rectangles are exactly the same. So that's how we find the total surface area of a cuboid. So here we have 2 times, what is W here? That's equal to 7. Length is equal to 9. Plus length is equal to 9. height, that's equal to, we have already calculated, that's equal to 5. And the third one, W, that's equal to 7. Height is equal to 5. That is the total surface area of the cuboid. Now, if you calculate this, here we have 2 times 7 times 9. It is 63. 9 times 5, it is 45. 7 times 5, it is 35. 45 plus 35, that is 80. 80 plus 63, that is 143, which is equal to 286 cm squared. It's the area, right? 286 cm squared. Okay, another example. Celine, can you read this question for us?
Yes. An open rectangular tank of length 16 centimeters, width 9 centimeters, and height 13 centimeters contains water up to a height of 8 centimeters. Calculate the volume of water in liters. B, the total surface area of the tank that is contact with the water.
Thank you. So as you see here, it's like kind of aquarium, right? Usually if you want to keep fish in your house, usually you can buy maybe a spherical shape or this rectangular shape or cuboid. So that's the water inside, but we cannot see the fish. Maybe fish are invisible here. An open rectangular tank of length 16 centimeters and 9 centimeters, width 9 centimeters and height 13 centimeters, contains water up to a height of 8 centimeters. Calculate the volume of water in liters, right? How do you find the volume of the water? So part A, volume of the water is equal to base area, that's 9 times 16, and we should multiply by height. That's equal to 8. So what is it? 9 times 16, that is 90, and 54, 144. 9 times 16 times 8, that's equal to 1152. That's equal to 1152. And that is cm cubed. This kind of volume problems, if the numbers are like decimal numbers or too big, you can just use a calculator, because here we are not learning calculation. We are learning how to calculate the volume and surface area. So how about question B? It says that the total surface area of the tank that is in contact, right, with the water, the part that is in contact with the water. That means that you can just suppose that we are talking about an open box, right? It doesn't have the top. Top is open. So that means that we are talking about, let's say, in a room, you have 4 walls and we have the floor. We don't have the ceiling. So at that time, how do we calculate this? That surface area will be, so actually the bottom is, right? The bottom part is the rectangle. That is 9 times 6. That it doesn't have the top. That's why I don't have to, I'm not going to multiply by 2. Plus, how about this side? As you see here, this container, this side and the other side, facing each other, they are identical. And also this part, right? And also the other side, the opposite side, also they have the same area because they are identical. That's why we have 2 pairs. I'm going to multiply them by 2. And inside here, this part is, this area is, what is it? It is 16 times height, right? Because we are just going to find the area that is in contact with the water. So that's equal to 16 times the height is 8. Plus, how about this part that's facing to you? That is just 9 times 8. That is the area of the rectangular tank, which is in contact with the water. Now, if you just calculate this, 9 times 6, that's equal to 54, plus 2 times 8 times 16, that is 128. 9 times 8, that is 72. And the 72 plus 128, that's equal to 200. 200 times 2 is 400. 400 plus 54, that is 454 cm cube. No. We're talking about area, so it is cm squared. Ilknur, is it clear? Did you understand?
Yes.
Are you sure?
Yes, I am. Also, can you please send these examples to the group?
Yes, yes. No, ignore. If I forget, just let me know.
Okay.
Mr. Qasim, can you share the slides with notes? Okay, if you just write this, I understand. I will share with you. And guys, next week you are going to have progress tests again from chapter 1 to 9 or 10. I don't know. May also actually include 10 or not. We will see. Okay, so from 1 to 10, 1 to 9, you're going to have exam next week. Actually, you're going to have exam during the class time. You should just come and join and solve the problems in 1 hour, and after that you will leave. So next question. What time is it? It's 9:35. Okay. A right prism is a solid which has two parallel planes of the same shape and size. Also, its lateral surfaces are perpendicular to its parallel ends. Okay, as you see here, the first one, that is right prism, and we know that a lot of buildings are prism shaped, right? And the bottom is the rectangle, top is a rectangle, every cross section area. Yeah, that means that if you just cut with a kind of knife that is parallel to the ground, the cross section area will be here. It is rectangle. It may be pentagon. And how about this one? We call this oblique. That's not perpendicular to the ground. Okay. So if you just draw this, as you see here, this angle is not 90 degrees. That's why we call this oblique. And how about the another one? As you see here, the base is pentagon, right? So that is pentagon base prism. So these are the lateral surfaces. As you see here, if pentagon, the top is pentagon, bottom is pentagon, and all lateral faces are rectangles. And how many rectangular faces does it have? Since the base is pentagon, it has 5 rectangular bases, right? This one is 1, this one is 2, this one is 3, this one is 4, and this one is 5. Okay, so how do you find the volume? The volume of this prism is, again, just base area multiplied by the height. Okay, that is how we calculate the volume of the prism. So these are some other examples for prism. A right prism has a uniform cross section, and the cross section of the prism is identical to the two parallel ends. As you see here, if you just cut from anywhere, they are rectangles. Anyway, so how do you find the volume of the prism? You should just find the base area and multiply by its height. We get the volume of the prism. So example, volume of cross section, blah, blah, blah. The first one, find the volumes of these prisms, right? And the first one, as you see here, this side is 6, and the width, it is 3, and height is 8, right? And now this is a kind of cuboid. So what is the volume? It is 3 times 6 times 8, which is equal to 3 times 6 is 3 times 8 is 24. 6 times 24, that's equal to 144 cubic feet. So how on the second one? The width is 2, length is 5, and the height is length is 10, height is 5. So if you just find this area, that's just rectangle, and multiply by its width, width will be here as height. So it gives us, and we get the volume of this prism. That is 5 times 10 times 2, which is equal to 100 cm cube. And how about the last one? The length is 7 inches and height is 4 inches, and the length of this prism is 15 inches. As you see here, also this prism is here, it is a cuboid. Cuboid is a special prism. So that's equal to 7 times 4 times 15. 4 times 15, 60. 7 times 60 is 420 inch cube. Okay, sound simple examples for prisms. I mean, the volume. And how about the surface area? I mean, to find the surface area, usually we have to unfold that actually solid. And after that, calculate each, what is it? The area of the face, and add them up. And we'll get the total surface area. If you look at this example, what we have here, we have pentagon base prism, right? So if you just cut along one edge, and after that also other edge, and if you just open this, we will get that thing, right? This figure. That is the net of the prism. So as you see here, the top is pentagon, the bottom is pentagon. They are exactly the same. And how many faces does it have? It has 1, 2, 3, 4, 5, 4, 5, and 6. It has 6 faces. Is it 6? Yes. Oh, here the base is not pentagon, the base is hexagon, right? So we have 6 rectangular, what is it? Faces. So now to find the total surface area, we should get the area of this bottom. Let's say it is A, and also this one is A. All these rectangles are, what is it? Identical. The areas, let's say it is B. This one is B. This one is B. This one is B. This one is B. This one is B. Now, what will be the total surface area? The total surface area will be A plus A. That is 2A. That is top and bottom, right? And the base. And here, how many sides? 6. So that's equal to 6 times B. So that is how we find the total surface area of a prism. Example. Draw a net of the right prism shown below, and then find its volume and surface area. First, actually, we are asked to draw a net of the right prism here. As you see here, in different ways, actually, I can draw this, right? I can just cut through here. I can cut through here, or I can cut through here, or I can cut through here, and after that, cut other parts. So that in this way, we actually can get the net of this prism. One way of doing this one is, how about if I just cut from here, right? The top and the bottom. As you see here, the top is right angle triangle, and also bottom is right angle triangle. So the length is, this one is 20, and this height is given, right? This one is 12. So here it is 12. This one is 12. Now, if it is 12, actually this should be, also you can find, it is side. How we can find this? Using Pythagorean theorem, we can find this. Anyway, so that is the net of this prism. First, let's find it is area. How do you find its, not area, volume? To find the volume, part A, to find the volume, we need to find the base area, right? And what is the base area? As you see here, base area is this one. We are talking about this triangle, right? As you see here, one side is 12 centimeters, another side is 16 centimeters. So this side is 16 centimeters. And how do you find the area of the base? So that is area of the base times height. And the base area is a triangle. That is 1/2 times base times height. That is 12 times 16. And how about the height of this prism? That's equal to 9. And now that's equal to 1/2 times 12. That's 6. 6 times 16, 96. And 96 times 9 is equal to 864 cm cubed. That is the volume of this prism. Part B, to find actually the, what is it? The total surface area. As you see here, we have 5 different figures, right? Not different, actually 5 figures. So that is a triangle, and also that's a triangle. So here, the total surface area, let me just denote this by S. Here we have S, right? And using just this formula, what we have here, perimeter of the base times height plus 2 times base. Why perimeter? As you see here, this is a big rectangle, right? That's 6 base means just find the length of this rectangle. That is length plus length plus length plus length, right? And the times, we need to multiply this by height, right? We need to multiply by height. Perimeter of the base, that's perimeter of the base, and multiply by height, plus 2 base areas. So what is the perimeter of this prism? Perimeter of this prism is, as you see here, the base prism is, that is 12, right? And another part is 16, and third part is, the third length is 20. So the perimeter is, what is it? 20 plus 12 plus 16 times height. What is the height? Height of the prism is 9, plus 2 times the base area, or the area of the top. So that is 2 times, what is the base? Base is the triangle, right? The area of the triangle is 1/2 times, we have already calculated here, that is 12 times 16. 12 times 16. That is a total surface area of this prism. So now if you just calculate this, and 12 plus 20, that is 32, plus 16, 48. Here we have 48 times 9, plus 2 times half is equal to 1. And here we have 12 times 16, which is equal to 48 times 9 plus 12 times 16. That's equal to 624 cm squared. Okay, 2 questions left, guys. After that, we will do some different question if we have time. İlknur, Adilhan, Ibrahim, Selin, guys, do you have any question? Why are you so quiet today?
No, I don't have any questions.
Yes, İlknur, I have a question for you. Can I ask you one question?
Yes.
So why don't you have any questions?
I'm listening to the lesson very carefully.
Okay, you're only listening, not watching,
Yeah, I'm also watching.
and also listening to music.
No, I'm listening to the lesson.
Now, these days, kids are very professional. Because as you know, I don't know you know or not, also I have 4 kids, and I think you are my son's age. My eldest son is 12 years old. He's going to turn 13 next month, February. And also my birthday is in February. The difference only 1 week. He was born on February 21. I was born on 28th of February, the last day. But fortunately, I was not born in leap year. And also my second daughter is 10 years old. She's going to turn 11 this July. And another son is, second one is 6 years old. He's going to primary 1. And my youngest one is daughter, 4 years old. Okay. So now these guys, sometimes when they are having online class in front of the laptop, actually their game is open. They're listening to music and also watching the lesson and also reading something. Okay, when they're just passing by, they just switch to the class. And sometimes I just see that they also play games, listening to the teacher and watching, and also drinking, eating. Multifunctional generation. Now this online class, the people changed dramatically, right? This year, in just 1 year. And can you remember, like last year, exactly this day last year, what were you doing? We were completely different, right? The last year
Yes,
you could
I was at
travel.
school.
Yeah, I had a plan. Actually, I had a plan to travel to other countries, and I went to Uzbekistan in November. I came back, and after that, I had a guest, and after that, I went to Malaysia. I stayed there about 2 weeks. And in March, I just came back home to Cambodia. After that, they canceled the flights. Everything started after that time, and now the world changed. I don't know, almost 180 degrees. So we are having classes online, and all right. So what we have to learn from here, Selin, Ibrahim, Adilhan, İlknur. Okay, I mean, what should we learn from this situation? As you see here, if you are a little bit hardworking student, if you are interested in learning, and if you have a little bit strong willpower, you know how to control yourself. Okay, when you have to stop playing games, you should stop playing games. When you stop wasting your time, like anything not related to learning, if you can control yourself, you can learn. And other people, if they are actually weak in controlling themselves and they have no goal, they just wake up, they don't know what they are going to do. They're just doing everything spontaneously. And this kind of people, they just stay like this, I think. And if you have a little bit interest, if you really like learning, if you enjoy learning, you will get more educated. And this is how we are living this in this world right now. And because a lot of people, if their parents force, they learn, otherwise they don't learn. Now learning is a kind of optional, right? You're not in the classroom, even I cannot see your faces, right? and but you are paying, but so responsibility is on you, you know. So you are paying and you have to learn. Okay, if you really want to learn, somehow you need to find a way to enjoy learning. Otherwise, you know, and like let's say 80% of the people or 70% of the people, that will actually remain the same. Even 1 year, 2 years pass the same. And after that, they will regret, of course. But what can we do? And guys, that's why you have a good opportunity. If you are tired before the class, you need to take a nap, maybe 30 minutes at least. You feel fresh, okay? And after that, come to the class and try to learn something. Because also daytime I teach, I get tired. If I just come and teach you directly, it's also very hard for me. So what do I do here? I just eat my dinner and go to my room and tell my kids, okay, do, but don't disturb me. Just play your games or read a book. I take a nap for like 30 minutes. So I feel fresh so that I can teach you well. Okay, that's what I suggest you guys. So let's solve two more questions and I will finish today's class. Volume and surface area of prism. Find the volume and surface area of the right pentagonal prism. As you see here, the base is pentagon, right? As you see here, if you just look at the base, rectangle plus triangle, they form a pentagon. So now to find the base area, right? Number one, we should find the volume, we should find the base area, and we should multiply this by height. And what is the base area? Base area, actually, we have a rectangle and a triangle. So this base area is the rectangle. The side is 5 times 6. So that is 5 times 6. 5. I don't understand what happened. Okay, the rectangle is 5 times 6. And how about the triangle? As you see here, triangle, that one is 3. And that is 4. And also this one shows that it's a right angled triangle, right? So its area is 1/2 times 3 times 4. That is the base area, the area of the pentagon. And times, we should multiply it by height. What is the height? That is 4.5, which is equal to 5 times 6, 30, and 3 times 4, 12. Half of 12 is 6. So 30 plus 6, that is 36 times 4.5. Okay, 36 is 144 and half is 18. So that's equal to, I think, 162, right? So the 36 and the times 4.5, that's equal to 162 cm cubed. That is the volume of this, what is it, solid. And question B, how about the total surface area? It says the surface area of the right pentagon prism. Okay, and to find the surface area, guys, here it says the surface area. How do you find this? To find the surface area, we need to find the perimeter of the base, right? The base is pentagon, and multiply by the height. So it gives us, what is it, all the sides, and plus top and bottom, right? Actually, the top and bottom, the area we have already calculated here, right? What is it? 30, it is 36. That's the area of the pentagon, which is a base. So now to find the total surface area, that is equal to the perimeter times perimeter of the base, let's say perimeter of the base, right, times height, plus 2 times base area. Let's say the base area. Let me just write here, base, which is equal to, what is the perimeter? Perimeter is, starting from here, perimeter is 3 plus 4, that's a rectangle, and continue, it is 6 plus, okay, it is plus 6 plus 5, and also this side is 6, so it is plus 6 perimeter, and it is 4 plus 3 plus 6 plus 5 plus 6, it's 5 sides, right? 1, 2, 3, 4, 5. That's the perimeter. And multiply by height. Height is 4.5. We should multiply by height. Plus 2 times top and base. What is the top and base? That's 36. So I should write here 36. which is equal to 3 plus 4, 7, 7 plus 6, 13, 13 plus 5, 18, 18 plus 4, that is 24, times 4.5 plus 72, which is equal to 24 times 4.5, that's equal to 108, and plus 72, that's equal to 180 cm squared. That is the total surface area of this one. That is our last question for today. Find the volume of wood used here, the key point, actually keyword used, in making an open rectangular box 2 centimeters thick. As see here, what's going on here? Okay, 2 centimeters thick, given that its internal dimensions are 54 centimeters, 46 centimeters wide, and 18 centimeters deep. Okay, internal. So internal means not including the thickness of this container. What is the question? Number, we should find the volume of wood used in making this, right? So to do this one, actually, we should find the volume considering the external dimensions, right? And minus the volume of the internal one. So like, for example, if you remember, if you're given a rectangle field, let's say, in the middle, we have a kind of garden, okay? So now to find the area of this pad, the shaded region, how do you find this? From this big rectangle, we should subtract the area of small rectangle, right? And also there's something like this. From the big volume, we should subtract the smaller volume. So what is a big volume? And the volume of the wood, let me just write here, volume of the wood is equal to volume of the big one and external minus volume of the small one, the internal one. Maybe I can just write here external and internal. This one is external and this one is internal. Equals, and what is the volume of the external? The length, right? This length is, what is it? That is 54 plus 2 plus 2. That's equal to 56 times, and the length is 46 plus 2 plus 2. That is 48 times depth is, it is 18, right? Plus 2. 18 plus, of course, also at the bottom, right? The thickness of the wood is 2 centimeters. So that is 20. Minus, now calculate the internal one, that is 54 times 46 times 18. So that gives us the volume of the wood that is used to make this, what is it? Rectangular box. So that's equal to 56 times 48 times 20 minus 54 times 46 times 18. That's equal to 9,048 cm cube. This much wood is used to make this rectangular box. Guys, thank you very much for today. Okay, try to practice these questions. I will send you one assignment and try to practice. And you are not asking questions. I can feel that maybe you're not practicing much. Once again, if you just continue like this, you will not learn much. You should come to the class with questions. Okay. All right, guys. See you on Thursday. Happy New Year again. Bye-bye. I'll meet you on Thursday.
Bye.
Bye-bye. Thank you.
Bye.